Coming up. 11:45 should be open.
At what time you told them? 11:15.
So I told 11:45 join. Who? Jaipur.
Yeah, you open.
Huh?
No, you do only some other system.
Ah.
You call Akshay. So you can talk. So the webcam is there. Camera is there.
I'll open this up through this.
Today is on leave. Check on leave today.
Already they started to join.
I saw that. Jaipur.
ಇದು ನಿಮ್ಮ ಮೇಲ್ಗೆ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಕಳಿಸಿ ಓಪನ್ ಮಾಡೋದು
ಸರ್
ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ನಿಮ್ಮ ಮೇಲ್ ಮಾಡಿದ್ದೀನಿ ಓಪನ್ ಮಾಡೋದು
ಹೌದಾ ಓಕೆ ಫೈನ್ ನೋ ನೋ ಇಟ್ಸ್ ಓಕೆ
Sir,
ನನಗೆ ಏನು ಮಾಡಿದ್ರು?
No. You okay? Now the webinar is there. No? We thought your laptop. Irli. Right. Okay, fine.
ಬರ್ತಾ ಇದೆ ಸರ್ ಇಲ್ಲಿ ಬಟ್ ಸ್ಕ್ರೀನ್ ಬರ್ತಾ ಇಲ್ಲ.
ಬರ್ತಾ ಇದೆಯಾ? ಹಲೋ
ಹಾಂ ಬರ್ತಾ
ಹಲೋ
ಬರ್ತಾ
ಜೈಪಾಲ್ ಕ್ಯಾನ್ ಯು ಸಿಟ್ ಆನ್
yeah, it's on, sir.
ಇಟ್ಸ್ ಐ ಥಿಂಕ್ ಇಟ್ಸ್ ಡನ್. ಸರಿ
It's on control.
ಇವಾಗ ಮಾತಾಡು ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಸೌಂಡ್ ಕಡೆಗೆ
ಹಾಂ ಸರ್
ಮಾತಾಡ್ತಾರೆ ಕೇಳಿಸ್ತಿರಲ್ಲ
ಈಗ ಒಂದು ನಿಮಿಷ.
ಇಲ್ಲಿ ನೀವು ಮಾತಾಡೋದು ಕೇಳಿಸ್ಬೇಕಲ್ಲಿ ಕೇಳಿಸ್ತಿಲ್ಲ ಅಲ್ವಾ
ಕೇಳಿಸುತ್ತೆ.
Few seconds.
now it is okay
This is the you will start also.
Yeah.
video thing is not there
ಓಕೆ ಸರ್ ನೌ ಇಟ್ ಈಸ್ ಸ್ಟ್ರೀಮಿಂಗ್ ಓನ್ಲಿ ಥಿಂಗ್ ಈಸ್ ಒನ್ಸ್ ಯು ಸ್ಟಾರ್ಟ್ ದ ಸೆಷನ್ ವಾಟ್ ಆರ್ ದ ಥಿಂಗ್ ಲೈಕ್ ಸಿಂಪಲ್ ಸೌಂಡ್ ಆಗಿ ಕೂಡ ಯೂಟ್ಯೂಬಲ್ಲಿ ಬರುತ್ತೆ ಅದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು ಅಷ್ಟೇ ಅನ್ನೆಸೆಸರಿ ಟಾಕ್ ಶುಡ್ ನಾಟ್ ಬಿ
ಸರ್ ನೀವು ಇಲ್ಲೇ
ಕ್ಲಾಸ್ ಇದು ಜಾಯಿನ್ ಮಾಡಲಾ
record ಮಾಡಿ
This okay.
HOD whether is free
ಸರ್ ಇದು ಏನು ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡ್ತಿರಲ್ಲ ಇಟ್ ವಿಲ್ ಸೇಮ್ ಥಿಂಗ್ ಇಟ್ ವಿಲ್ ಕಮ್ ಇನ್ ದ ಯೂಟ್ಯೂಬ್ ಓಕೆ ವಾಟ್ ಆರ್ ದ ಥಿಂಗ್ಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಪೀಕ್ ಆಫ್ಟರ್ ಮ್ಯೂಟಿಂಗ್ ಹಿಯರ್ ಆಲ್ಸೋ ಇಟ್ ವಿಲ್ ಬಿ ರೆಕಾರ್ಡೆಡ್ ಇನ್ ದ ಯೂಟ್ಯೂಬ್ ಇಟ್ ವಿಲ್ ಬಿ ಕಮಿಂಗ್ ದ ಯೂಟ್ಯೂಬ್ ಸೊ
Now it is coming, no?
Now it's coming. Now it's already YouTube live is there.
Okay.
But you are not share the YouTube live link to the students.
Okay.
Okay, once you start the session, everything
time
will
will
be
share.
streamed in the YouTube. If you mute here also, if you talk anything,
No,
that
once
will
you
come with YouTube.
program.
no problem
Oh, anything.
That
See, now we'll start.
time
So came up.
How many are there?
11 join.
So let them join, sir. Still they have to join.
Thing is, if you are mute here also, in the YouTube something come. ಏನೇ ಮಾಡೋಣ ಅದು
What ಮಾಡೋಕ್ಕಾಗಲ್ಲ.
sir good morning sir
ಏನು
ಈಗ
mute
he is calling Jaipal is calling
ಹಾಂ
So
ಸರ್
join, sir. I think JP.
ಆಡಿಯೋನ ಮ್ಯೂಟ್ ಮಾಡ್ಬೋದು ಅದು ಸೆಟ್ಟಿಂಗ್ಸ್ ಡಿಸೇಬಲ್ ಮಾಡಿದೆ ಬಟ್ ಅದು ಮ್ಯೂಟ್
okay start ಮಾಡೋಣ
ಸರ್ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಬರೀ 15 ಇದ್ದಾರೆ. Let them join.
Sir,
time ಇದೆ
ಹಾಂ
sir good how are you sir yeah correct yes I think thing is around 12 we are starting and students also joining other students
Link already sent.
it is okay sir you are joined there is no problem
No need of mic.
1 minute it is there
Sir.
we are able to see him.
ಶೇರ್ ಮಾಡಕ್ಕೆ ಹೇಳು
JP it is there.
JP, sir. Name.
video is there
Video not coming, sir.
Ask him to share.
Sir, that is JP, no, sir? JP. Yeah, JP it is there, but that video screen is not.
Has to present, sir.
Hmm?
Sir has to present.
Sir, speaker has to join.
Now it is okay. Now you are visible, sir. Now you are visible. Earlier that video was not there.
Screen share.
Now video has come. And we'll do one thing, sir. Initially, we'll start and then just briefing we'll do. We'll make some 5 minutes and tell about introduction about you to students, and then after that we will start. So 12 o'clock we'll start this program. Link is established and students are joining because we have given them time of 12 o'clock. Okay. Yeah, link is there now. No problem. Okay, sir. Right.
Sir, switch on video. Mic not required no, for this.
Mic is not required. You tell sir to share their presentation also. Because if you are not joined through Google Chrome, you can't present their presentation through
Google?
He has to join Google Meet through Chrome only. If you are joined through Mozilla or some other things, you can't share the presentation. He has to share the presentation.
Oh.
Sir. We'll call.
Or let him send presentation.
ಇಲ್ಲ ಅವರು ಕ್ರೋಮಿಂದ ಜಾಯ್ನ್ ಆಗಿದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಅವ್ರಿಗೆ ಒಂದ್ಸತಿ ಟ್ರೈ ಮಾಡಕ್ಕೆ ಹೇಳಿ ಸರ್ ಪ್ರೆಸೆಂಟೇಷನ್ ಅವ್ರು ಶೇರ್ ಮಾಡಕ್ಕೆ ಹೇಳಿ ಇಫ್ ಇಟ್ ಈಸ್ ವಿಸಿಬಲ್ ಮೀನ್ಸ್ ಫೈನ್
Yes, yes, so.
presentation is visible.
No.
His video was.
Video will come now. You can't share the presentation.
Sir, once you are presenting, actually your presentation you have to only show through Chrome only, not through Mozilla or other things. Through Chrome only, but once you can show that presentation, whether it is visible, we will see. If it is visible, again you can close that, and then after that you can be there. Yeah, we are checking. We'll check. Just one minute. No, Mozilla. No.
No.
It did not come.
Sorry, it's presenting. Sir, it's not coming here.
No, sir, it is not there. Otherwise, you send the presentation.
One second, sir, one second.
You click on.
It's
No,
coming.
it is there, sir, now. Now it is there. Yeah. Okay. Yeah, clarity is there, no problem. Okay, fine. Then,
Let it be.
Huh?
Let it be on, sir.
okay, let it be on only, so that we'll initially start the briefing about you and other things. Will take around 5 minutes. Then after that, you can straight away start the presentation. Okay, sir, let it be there.
Once presentation starts,
Fine.
you don't talk anything. Only speaker is speaking, you should all should be silent.
Okay.
Because in the YouTube, what are the things we discuss here, it will be streaming in the YouTube.
ಇವಾಗ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆಲ್ಲ ಮ್ಯೂಟ್ ಮಾಡ್ಬೋದಾ?
All are muted.
Students in the YouTube, student can't talk anything. Only they can text in the chat box in the YouTube.
Okay,
In the Google Meet, regular what discussion, those things can be happen. Okay. Only thing is you are going for YouTube, right? Whatever the sound, small sound will generate here, that will go for YouTube, like that's it.
ಬನ್ನಿ ಶ್ರೀಕಾಂತ್, ವೆಲ್ಕಮ್.
ಸರ್ ಇವಾಗ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ.
So session start ಆದ್ಮೇಲೆ ಯಾರು
ಸ್ಟಾರ್ಟ್ ಮಾಡಿ.
ಯಾರು ಮಾತಾಡ್ತಾರೆ?
Sir, 12 o'clock na? Will not take much time.
ಏನ್ ಮಾತಾಡ್ತಿದ್ವೋ
It will start.
ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ಇರ್ಬೋದು ಅಂದ್ರೆ ಸೌಂಡ್ ಆಗ್ತದೆ ಅಷ್ಟೇ. ನಾವು ಒಂದ್ ಸ್ವಲ್ಪ ಸೌಂಡ್ ಮಾಡಿದ್ರೆ ಅದು ಡಿಸ್ಟರ್ಬ್ ಆಗ್ಬಿಡ್ತದೆ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ.
Turn off on
ಹೌದಾ?
ಅಲ್ಲ, ಇದು ಅವರು ಪ್ರೆಸೆಂಟೇಷನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ಮೇಲೆ ನಾವು ಮ್ಯೂಟ್ ಮಾಡ್ಬೋದಾ?
ಇಲ್ಲಿ ನಾವು ಯೂಸ್ ಮಾಡಿರ್ತೀವಿ ಸರ್, ಬಟ್ ಅಲ್ಲಿ OBS ಸಾಫ್ಟ್ವೇರ್ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ, ಸ್ಕ್ರೀನ್ ಶೇರ್
ಬಂದೇ ಬರುತ್ತಾ?
OBS ಸಾಫ್ಟ್ವೇರ್ ಆಡಿಯೋ ಮ್ಯೂಟ್ ಮಾಡಬೇಕು. ಮ್ಯೂಟ್ ಮಾಡಿದೆ, ಡಿಸೇಬಲ್ ಮಾಡಿದ್ದೀನಿ, ಬಟ್ ಆದ್ರೂ ಬರ್ತಾ ಇಲ್ಲ.
ಸರಿ ಸರ್.
ಸ್ವಲ್ಪ
Then we should not talk.
ಹಾ,
Once
let's
it
see.
starts.
ಇಲ್ಲಿ ಮ್ಯೂಟ್ ಆಗಿರುತ್ತೆ ಗೂಗಲ್ ಮೀಟ್ ಅಲ್ಲಿ
ಗೂಗಲ್ ಮೀಟ್ ಅಲ್ಲಿ ಅಷ್ಟು ಏನು
ಅಲ್ಲ
ಕೇಳಿಸಲ್ಲ.
ಆಗಿರಲ್ಲ.
ನಾವು ಮಾತಾಡೋದು ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಅಲ್ಲಿ ಎಲ್ಲ ಕೇಳಿಸ್ತಾರೆ.
ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ
ಅನ್ನ ಶೇರೇ ಮಾಡಿಲ್ಲ ಲಿಂಕ್ ಸೆಷನ್ ಸ್ಟಾರ್ಟ್ ಆದ್ಮೇಲೆ ಶೇರ್ ಮಾಡಿ ಅಂತ.
ಇವರೇ ಮಾಡ್ಬಿಡಿ ಜಾಯ್ನ್ ಆಗಿ.
ನಾವಿಲ್ಲಿ ಮಾತಾಡೋದೆಲ್ಲ ಕೇಳಿಸುತ್ತೆ.
ಆಯ್ತು ಸ್ಟಾಪ್ ಮಾಡೋಣ ಇವಾಗ. ಸ್ಟಾರ್ಟ್ ಮಾಡಿಸ್ಬಿಡಿ.
ಸ್ಟಾರ್ಟ್ ಆಗಿ ಸರ್ ಲಿಂಕ್ ಶೇರ್ ಮಾಡಿದ್ರೆ ಸಾಕು ಸ್ಟೂಡೆಂಟ್ ಜಾಯ್ನ್ ಆಗ್ತಾರೆ ಯೂಟ್ಯೂಬ್ಗೆ.
ಎಲ್ಲ ಕೊಟ್ಬಿಡಿ.
Make him mute once.
ಜಾಯ್ನ್ ಆಗ್ಲಿಕ್ಕೆ ಬೇಕು ಅಂತ ಹೇಳಿ.
ಇಟ್ ಈಸ್ ಮ್ಯೂಟೆಡ್. ಓಕೆ ಓಕೆ ಫೈನ್.
Monshi something. Mute okay. We start. Can I talk?
HOD ಫ್ರೀ ಇದಾರಾ?
If you want to practice, you just open you share that link, open Google Meet from HOD laptop, and so that you can do a interaction speech.
ನಾವೇನಾದ್ರೂ ಹೇಳ್ಬೇಕಂದ್ರೆ ಈ ಮೊಬೈಲಿಂದಾನೆ ಹೇಳ್ಬೋದಲ್ಲ.
ಇಲ್ಲ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ
ಅಲ್ಲಿ
ಅಂದರೆ ಇಲ್ಲಿ ಆನ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದ್ರು ಇಲ್ಲ ಇಟ್ಕೋಬೋದು.
ಎಲ್ಲೂ ಸೇರಿದ್ದೀವಿ ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಹೋಗ್ಬೋದು.
ಮಾತಾಡೋದಲ್ಲಿ ಯೂಟ್ಯೂಬ್
ಫಸ್ಟ್ ಇದು ಸೊ ಅಂದ್ಬಿಟ್ಟು ಡಿಪಾರ್ಟ್ಮೆಂಟು ಫಾಲ್ಕನ್ ಏರೋವಿಷನ್ ಹೇಳ್ತೀನಿ ಸರ್. ನೀವು
Just few things, then we will brief. I will tell, we will brief. Then start.
on
ಮಾಡ್ಬೇಕಾ?
here
ಆಲ್ಮೋಸ್ಟ್ 30 ಸೆಕೆಂಡ್ಸ್.
this link you will just share with our students class or non-registered students. Like that we share.
ನೇಮ್ ವಿನೋದ್
That is okay. But now after once I start, you just share. Sorry, close one. We'll start.
ಸ್ಟಾರ್ಟ್.
12.
ಓಕೆ. only one side.
I'll just talk here only so that it won't echo.
Then this mute this.
And that I'm muted.
I think it's on.
Good morning to one and all.
Good morning, sir.
It gives me an immense pleasure to invite you for the national level webinar series Aerovision 2020 on advancements in aeronautical and aerospace engineering. So which will be held from 2nd November to 6th November 2020 in association with Falcon Aeronautical Students Association. So I will be happy to give the introduction talk. The Department of Aeronautical Engineering was started functioning in the year of 2011-12 with the approval of AICTE and VTU. The Department of Aeronautical Engineering is the youngest and most dynamic department at NMIT. The vision of the department is to develop technically competent aeronautical engineers of highest academic standards to meet the national and global requirements of industry and society. The Falcon Aeronautical Students Association, which is named after the bird falcon, was started in the year 2014 by the students of aeronautical engineering. Falcon organizes co-curricular and extracurricular activities to develop interpersonal and intrapersonal skill of the students. It organizes seminars, quizzes, program, industrial visits, guest lectures, career guidance, and aero modeling under its auspices. It is an exciting place where the faculty is friendly, well qualified, and able to provide excellent supportive environment for the students to study. Since the test of time, man has been fascinated by flying, and it is seen and depicted in many religious myths, stories, ancient philosophies, and several incidents of history. These carry certain mysterious facts and flying technologies moving back to few thousands of years. For instance, we nearly every Hindu and Buddhist in the world, hundreds of millions of people have heard of ancient flying machines referred to in the Ramayana and other texts as Vimanas. The word Vimana originates from Sanskrit words Vimana, V meaning bird, Mana meaning like. The interpretation of will be like a bird. Among many significant contributions of ancient Indian scientists, Vaimanika Shastra, that is aeronautical engineering, is notably towering work dealing with Vimanas and allied topics. In the recent years, rapid advances has been taken place in the field of aeronautical engineering and aerospace engineering. This 5-day national level webinar, AeroVision 2020, on advancement in aeronautical and aerospace engineering, which will be held under the aegis of Falcon Aeronautical Students Association from 2nd to 6th November 2020, has therefore been organized to provide a forum for imparting special knowledge and hands-on experience in the area propulsion, aerodynamics, structures, space mechanics, unmanned aerial vehicles, micro aerial vehicles, additive manufacturing, etc. During this webinar, the eminent personalities from the industries have been invited, and they are going to deliver the talk on various fields of aeronautical and aerospace engineering. Thank you. I would like to request the chief coordinators of the webinar AeroVision 2020, Dr. P.N. Tengli sir, to talk about the AeroVision.
Good afternoon, everyone. On behalf of Principal NMIT and HOD Aeronautical Department, I welcome Dr. P. Jayapal, who is today going to be the chief guest and keynote speaker. And also I welcome all the students who have registered, and today they are going to participate and make a very good interactive session today. So it is very good session, and it is very useful to all of you. And today Dr. P. Jayapal, he is having a very vast experience and he is going to speak on safety aspects of aviation. He was chief executive at Semilac DRDO and he has got a very vast experience, and I request all faculty and students to interact, and then any doubts are there, those things can be clarified with him. And afterwards also you can interact with him, and also any doubts, anything, he is very much helpful to our aeronautical fraternity, and we should make use of that. And this 5 days seminar, there are very good speakers are there. I request all students not to miss any of the sessions. So this is from 2nd to 6th, all the 5 days between 12 to 1. The sessions are arranged, and the speakers are Dr. Prahalad Ramarao, Distinguished Scientist, DRDO, and he will talk on flying on technologies, and Dr. P.S. Subramaniam, former Director, ADA, Bangalore. So he will talk on technology advances for future fighter aircrafts. And Dr. M.C. Uttam, he is a director from ISRO, UOP. He will speak on challenges that shaped ISRO's launch vehicle program and its culture. And this talk also very much useful, and he is from ISRO. And Dr. Chandrasekhar U, Program Director from Wipro 3D Bangalore, he will talk on additive manufacturing related to aeronautical and aerospace engineering. And all these 5 speakers have got elaborate experience, and they are going to speak in a very good manner. I request all students and faculty not to miss any of the sessions and attend all the sessions, and then make a very good interactive session, then make it a grand success. So with this, I request Sridhar to introduce our today's speakers, about him, his achievements and all that. Okay, I now welcome Mr. Sridhar to tell about P. Jayapal.
Good morning, everyone. I'm Sridhar, Assistant Professor, Department of Aeronautical Engineering, NMIT Bangalore. On behalf of our department, I'm very much proud to introduce our chief guest, Sri P. Jayapal. Sri P. Jayapal is an outstanding scientist, retired as Chief Executive from Center for Military Airworthiness Certification, Semilac DRDO, Bangalore, on 31st May 2019. He is an alumnus of Madras Institute of Technology, MIT, Anna University, Chennai. He obtained his BTech in Aeronautical Engineering in 1983, in ME in Aero Engineering 1985. He joined DRDO in 1985 and worked in Regional Center for Military Airworthiness, RCMA, Nasik, and ensured the continued airworthiness assurance to all mixed series of aircraft manufactured and overall at HAL Nasik division. In 1990, he joined RCMA Helicopters, Bangalore. During his service at RCMA Helicopters for more than 2 decades, he certified the indigenous design and developed different versions of advanced light helicopters, ALH for Army, Air Force, Navy and Coast Guards, and light combat helicopters, dedicated attack helicopters. He also accorded airworthiness clearance for light utility helicopters for carrying out development and certification flight testing. In 2013, he became a group director, Aircraft Semilac. There, he was responsible for leading and guiding 5 RCMAs located at different parts of the country, which are responsible for ensuring continued airworthiness assurance to the aircraft, transport aircraft, helicopters, airborne systems, unmanned aerial vehicle, weapon integration and indigenization of airborne items for achieving self-reliance on aviation. He took over Chief Executive Airworthiness, Center for Military Airworthiness and Certification, CEMILAC in 2014. As Chief Executive, he was controlling the airworthiness and certification activities undertaken at 14 RCMAs located at different parts of the country for all kinds of platforms, airborne weapons systems, and all integrations, upgradations, and indigenous items developed by the DRDO, HAL, CSIR, PSU, and private organization for service use. After his education, aeronautical engineering at MIT served to the nation for 34 years and contributed significantly to the aviation, particularly our armed forces, and superannuated from service 31 May 2019. So now I request our chief guest to give a keynote address to the participants.
Good afternoon to everybody. Thank you very much for a nice introduction.
Yes, sir. Thank you, sir.
At the outset, I would like to thank the management and Department of Aeronautical Engineering, NITI, University Institute of Technology, Bangalore, for considering me and inviting me to give a presentation during the webinar on advancement in aeronautical and aerospace engineering. I thank Dr. P.N. Tengli, advisor, Department of Aeronautical Engineering, NMIIT, for remembering me and inviting me for a talk on these occasions. Dr. Tengli and myself worked together in the DRDO Aero Cluster Lab and had a very good interaction on various aspects. I congratulate Falcon, the Aeronautical Students Association of NMIIT, for initiating and conducting this kind of talks so as to enrich their knowledge in the field of aeronautical engineering. I thank all the students who has participated in this webinar. Okay, as Dr. Tengli says, it is an occasion to expose yourself what is happening in the country in the field of aviation. Today, I am going to give a presentation on the safety aspects in aviation, in particular to the manned vehicles, that is aircraft and helicopters. Safety is a critical requirement which has to be ensured by the designers, manufacturers, inspectors, maintenance personnel, and the operators of the pilot. Today, my talk is restricted to how safety is ensured to the flying machine, that is aircraft and helicopters, in the form of certification. Are you seeing my slide? Hello? Hello?
Yes, sir.
You are seeing my slide?
Video
Am
is
I audible?
visible, sir.
Video?
Video is visible, sir. Presentation is not coming.
Hello? Presentation is not coming.
Yeah, yes, sir.
Just a minute.
Yes.
Now also?
1 second, sir. It's coming now. It's not coming, sir.
Not coming. Okay. So slide, you are not able to see the slide, eh?
Yes, sir.
Just a minute.
For you. For you also not coming. No. Your Google Meet link. It's not coming. Yeah, sir. Now it's visible, sir.
Okay?
Yes, sir.
Audio,
Yes, yes,
audio,
sir. Now audio is okay, video is okay, sir.
Sir, you can go ahead, sir. Sir, you can go ahead. Sir, you can go ahead, sir.
Okay. Okay, thank you very much. Safety is an important critical requirement in each and every aspect in life. Even whenever we are moving out of our house, our parents used to say, be safe and be careful. So safety is a very, very critical requirement in each and every part of the life from day-to-day aspects. In our normal life, safety is very important. The aviation safety is much more critical. That we are in the air. If any safety is anything happens, there is no chance. Okay. For that, aviation safety is a much more critical. So safety in aviation to be ensured with a zero tolerance. That all of you are aware. Airborne platforms to be built safe to fly. The platform in the sense whether the manned aircraft or helicopters, the civil or military, all the platforms have to be built safe to fly. What is safe to fly? The product must be airworthy. The product in the sense that is the aircraft or helicopter, it must be airworthy. Airworthy, would say, it's a fitness to fly. If you take our vehicle to the RTO office, two-wheeler or car, you will certify your vehicle is roadworthy, you give a certificate. Similarly, our flying vehicle, the aircraft or helicopter, it should be airworthy, that is fitness to fly. The products to be certified by external agency. External agency in sense, other than the designer, other than the manufacturer, other than the maintenance engineer, the external agency has to audit your design and certify the product. Product shall be highly reliable and built with components of high reliability. If take today, Boeing 777, it takes off from Bombay or Delhi, goes to New York about 19 to 20 hours of non-stop flight. So imagine what is the safety has been built in, so that similar amount of safety has to be built each and every system of the aircraft. It's a high degree of quality control. That is what each and every stage there should not be any deviation without anybody's knowledge. Okay, and that quality control is a very important stages in all aspects, right from design till delivery and finally with the operation of the sources. Maintenance of the product must be as per the approved maintenance schedules. That is step. Then flight operations shall be clear, they have to fly the aircraft as per the cleared flight envelope. Why airworthiness? I told you, if you want to ensure the safety, it should be airworthy. Why airworthiness? Flying is a hazardous mode of transport that all of you are aware. With an aircraft and helicopter, it has been assembled with thousands and thousands of machined parts. With thousands of machined parts, no machine can be designed which never fails. One day, something or the other will fail. And any amount of system in place, the human error never be totally eliminated. Thus, certain reduction of safety has to be tolerated in any system, either in the day-to-day activities or any other industry or in the aviation also. Airworthiness evaluation becomes a question of mitigating the risk and assessing the level of risk which is acceptable. In simple words, you can say airworthiness is fitness to fly. And if you see the international airworthiness agencies are USA, the FAA and the Ministry of Defense, UK, France, Russia. If you come into India, for the DGCA, for all the civil aircraft, DGCA is taken care. For the military aircraft, Center for Military Airworthiness and Certification, CEMILAC will take care of the airworthiness and certification and quality assurance by DGAQA. What is CEMILAC? Center for Military Airworthiness and Certification is one of the DRDO organization which is assigned with the responsibility of ensuring the airworthiness and certification of airborne systems for military use. Any system developed by DRDO or PSUs like HAL and Bell or private organization has to be certified by CEMILAC before the product is inducted into military service for military use. There are 18 RCMAs under CEMILAC are spread across the country, giving airworthiness coverage for the certification activities. I told you, system developed by government, that is either DRDO or CSIR, PSUs, HAL, BEL, and private sectors has to be certified by RCM and CEMILAC before its use in aircraft, helicopter, and aero engine. CEMILAC accords clearance for. See, this is what happened after giving a certificate. Even CEMILAC accords clearance for the life extensions, mid-life upgrade, modifications of licensed built and bought out aircraft, helicopters, and aero engines. And there are in India there are several aircraft and helicopters are built licensed to the built to the print and bought straight away. For those platform also CEMILAC has to give clearance to ensure the continued airworthiness in the above aspects. CEMILAC and RCMAs adopt concurrent certification methodology, means be with the designer right from the project stage onwards for certification on all items. I told you there are 18 RCMAs located across the country and giving airworthiness coverage for all the developments happening at various centers. CEMILAC is the corporate office located in Bangalore. What is the charter of duty? CEMILAC, it will give a design clearance and certification for the indigenous design and developed aircraft, helicopter and system. If you take LCA, Advanced Light Helicopter, Light Combat Helicopter, Light Utility Helicopter, HT-40 trainers, and whatever the engine developed by GTR and everything, all those products, CEMILAC has to give a design clearance as well as certification. Once it is certified and delivered to the customers, ensuring the continued airworthiness till the product is retired from the service. This airworthiness, continued airworthiness is ensured to indigenous aircraft like LCA, ALH, etc. and licensed built aircraft like Jaguar, MiG-21, MiG-27, Su-30 and helicopters like Chetak and Cheetah and bought out aircraft like Mirage 2000, Jaguar and the presently inducted Rafale aircraft. And when you are buying this, all these bought out aircraft, the technology is advancing in a rapid way. Therefore, in order to keep the operational up to date, you have to do the modifications, upgradations, and for that also CEMILAC is giving clearance. Due to commercial reasons, one of the bought out aircrafts are provided with a limited life. Even though potential exists, due to commercial reasons, they are assigned very less life. So, in order to utilize the full potential, we carry out some exercise and give the life extension. The life extension clearance is accorded by CEMILAC. Then a type approval to the aircraft, systems, LRUs, raw materials and consumable also has to be accorded by CEMILAC. Whenever the aircraft or helicopter are in operation with Army, Air Force, Navy and Coast Guard, there always some incident and accident takes place. CEMILAC as a airworthiness authority will participate in the accident and accident investigation, identify the root cause for the incident and accordingly evolve a remedial measure to stop occurrence of such uneven events. Airworthiness directives. This I told you 18 RCMAs located across the country and all of us has to follow a uniform policy towards that. CEMILAC issues airworthiness directives to the RCMAs, the HAL and other services. Process certification refineries. Today, all the aircraft and helicopters, they use the fuel. CEMILAC goes to the refinery, audit their process and give a certificate so that a correct fuel is used for the aircraft or helicopters. And the Directorate of Aeronautical Quality Assurance Organizations. It is DGAQA located in Delhi. Under the DGCA regional offices are located, and each and wherever Semilac is there, they are located. And their aspects is quality inspection, conformance to standards, process, etc. Quality control and acceptance of airborne source. This is, I told you, quality control has to be ensured, and each and every stage of that development, their involvement is there. What is quality? Doing job right first time and every time is the requirement of quality in production. If you do this one, the product what we are manufacturing, what you are certifying, what you are delivering will have a highly quality, highly reliability product. This quality involvement, that quality control lead to reduce the level of non-conformance, scrap, which will result in higher productivity. If the quality control is not at each and every stage, the last moment you are inspecting, if it is not meet the requirement, if you reject, that will go as a scrap, the loss to the management and everybody. So involvement of quality control from the design and development stage itself reduces non-conformance of the product. I told safety. Safety means fitness to fly. Fitness to fly means the product is airworthiness. What is airworthiness? Airworthiness is a common. It is a helicopter or aircraft, any system. It is a common. Airworthiness is defined as the capability of an aircraft, helicopter, or a system to perform its intended mission. What is the mission? If it is a passenger aircraft, it has to take the passenger and cargo, take off from Bangalore, go to the nearest, wherever the near other airport, land safely and bring back. That is a mission with a clear envelope and specified life under all operating environmental conditions with acceptable level of safety and reliability. This is the definition for aircraft. There are some aspects: mission, specified life, environmental conditions, safety and reliability. These all the things has to be ensured during design till it is certified. How are you going to ensure? If we see the mission, there are various activities required to see these aspects are met. Mission requirement, performance, satisfactory function of the system. If you fulfill this requirement, you can say you can perform the mission satisfactorily. Specified life. If you see any aircraft, helicopter, you cannot use permanently forever. It has got a specified life. If you see LCA, it has got a it is designed for a specified few thousands of hours of life. As and when complete that few thousands of hours, it will be retired from service. Similarly, a passenger aircraft will be cleared for thousands, lakhs and lakhs of flight hours. Because if you see Boeing 777, it takes off from Bangalore, go to New York, lands within 4 to 5 hours, to change of crew, flies back. If you count number of hours, it will be lakhs and lakhs of hours. So for that, what you have to do? You have to do a endurance testing and fatigue testing to decide about the life. The environment condition, the product what you are designing and development and using, it has to meet the high and low temperature, high altitude, humidity, vibration, acceleration, environment, EMMC, lighting protections. For all to meet all the requirements, the product what you are developing, it has to undergo a testing under all these conditions. Then safety, you have to carry out the safety analysis, hazard and risk analysis, safety margins, all those things. Finally, reliability, endurance of the product, FMEA, FMECA, and reliability estimates. By carrying out all these activities, you will say your product is airworthy. If I told you, the environmental condition, if you see India, the dry and cold regions in Siachen will go up to minus 55 degrees centigrade. Dry and hot region at Rajasthan plus 52 degrees centigrade. Humidity at the hot, that is 50 degrees centigrade and greater than 99% relative humidity. Sandstorms, salines, high altitude airfields, Leh and Siachen, heavy and cross continuous rainfall sink. The product what you are developing by DRDO, by HIL, we are operating across the country. So the product has to be cleared to operate in this adverse weather condition. For that, each and every system has to be exposed to this kind of extreme environmental and tested and say the product is airworthy. For that, what we are going, I say airworthiness, I given a definition is a continued air capability of a product to perform satisfactorily and fulfill mission requirement throughout specified life in the prevailing environment and accept the level of safety and reliability. Certification. What is certification? Is a declaration of a conformance to the standards and specification of the product. End of the day, when any system, the Semilac or RCMA will give a certificate. That is the certificate. Airworthiness is the explicit declaration that the product, it is an aircraft or helicopter, is paid to be airworthy. End of the day, if a Semilac is giving a clearance, airworthiness clearances, you can say the product is airworthy, all the safety norms are ensured, the flight is airworthy, it is, you can say safety is ensured. How are you going to do all these things? If you see methodology for certification now, the requirements, who is the end user? In India, Army, Air Force, Navy and Coast Guard. In the form of joint services qualitative requirement, a specification comes. The specification has to be converted. It is the specificity, we say, based on the requirement, HLR, DRD with the order has to develop an aircraft. That all the requirements, this will be converted in the form of a technical specification. After finalizing the technical specification, the design evaluation starts. You are doing the detailed design, a preliminary design, critical design, and design for all the aerodynamic structure, systems, system integration, performance, and all the analysis, FMEA, critical analysis, simulation, static and dynamic testing, software, IB&B, testing and documentation. It is going on, yes, majority of the time it takes about 7 to 8 hours will take place. You are designing a system, it is undergo series of reviews, you have to manufacture a prototype and do the ground test and other simulation test. The day it is meeting all your safety requirement, the regulatory agency will give the clearance for the first flight. After meeting all the systems to the safety requirement, when the prototype first flighting starts, it is carriers of flight testing at various environments, as I told earlier, right from sea level to high altitude, various extreme environmental conditions, the flight testing is carried out. And after the flight testing is carried out, you are analyzing the data, and whether the whatever you have designed, manufactured, tested, it is meeting the service requirement. That is for data reduction analysis and compliance to the performance requirement. What services want some performance and what is the product you have developed, it is meeting the performance, and you are complying and creating a type record. And the type record you are submitting to the regulatory authorities like Semilac. Then they give us clearance for service use in the form of initial operation clearance or final operation clearance. And based on this IOC and FOC, our services, I mean Army, Air Force, Navy, will get the product from the HAL and they use for safeguarding our nation. I told you what is the product life cycle. The conception, right from the requirement from the joint services, it is then conception, design and development, and testing and delivery. There, based on the clearance or FOC, that final operation clearance given by Semilac, you are manufacturing, giving the product to services. There, the matter does not end. Thereafter, you are continuing to do airworthiness starts till retirement of the product. I mean, whenever during the operation, some kind of problem will come, you have to repair the system, you have to maintain the system. As the technology advancing, you have to upgrade the system to the latest technology and finally retirement. So the SEMILAC, the certification agencies, shall be involved throughout the entire development, beginning with the requirement comes from the services and continue till the requirement of the aircraft, aero engine, airborne store, weapon, etc. Now, the requirement comes from, I told services. It goes to the DRDO organization, ADA, DPSUs, BEL, HAL, and private organization. They are the design, development, testing, and manufacturing authority. And if you see a certification, SEMILAC, and quality control is DGA QA. Finally, it has to go back to users, I mean that Navy, Air Force, Army as operators. Now, each and every organization has to play a role. In this case, just because these authorities available with the external agency SEMILAC and DGQA, they cannot ask more. Okay, and they cannot ask less. All these organizations have to be follow a guiding document. Okay, one guiding document has to be there so that each and every organizations within their roles they have to play. That is called, what is that guiding document? DDP MOS. The document on design, development, production of military aircraft and airborne stores. This guiding document will talk about the roles and responsibilities of the designers, the manufacturer, the certification authority SEMILAC, the quality control authority DGQA, the flight test agencies, and user and operators. If anybody is deviating this document, they can clearly say it is not as per DDP MOS. You are asking more like that. This document is approved by Secretary R&D DRDO and Secretary the Production, the Defense Production. This is a guiding document being followed by each and every organizations. And this talk about concurrent airworthiness, indigenous design and development, licensed projects, bought out aircraft, development flight testing, user flight testing. Similarly, this is a volume 1. Volume 2 will talk about the software. Today, all our systems are software oriented. So the software certification, there's separate volume is there, and there is for unmanned vehicle also the DDPUAV is there. Sometime back we have released this document 2002. It was available for sale at the English Book Center, Kennett Circus. When I was in helicopter, this document has been purchased by many of the foreign countries. And one day when I was there, I received a call from Israel. Mr. Jaypal, I am doing a modification on so-and-so helicopter, Chetak helicopter. As per DDP MOS, I have to do this, I have to submit the document and everything. Okay, when can I submit? To whom I can submit? That is the level of this document has been being followed by encoding the abroad who are doing some kind of activities to our Indian platforms. This is the guiding document. It will be available in all the institutions of wherever the design and development of aircraft, helicopters are happening. Okay, whenever any product you are developing, there are different stages are there. Then the beginning itself will evolve a route to certification. For anything, everything, if you start, you have to go to the destination, there is a route. So I say there is a feasibility study on ASR, NSQR, GSQR. Now the services, today the advent of internet, services, they'll go to the internet, they can select what is available best in the country and everything put together, they'll ask. Finally, you have to see whether it is feasible to develop or not. Because putting all the state of the art together, sometimes it is may not feasible to develop. So the feasibility study on the requirements stipulated by in the ASR, NSR, GSQR. Then that requirement has been converted into a form of technical specification that has to be approved by all the stakeholders. So that the technical specification is approved by the designer, the certification agencies, the regulatory agencies, and the user. There is no any controversial even after 5 or 10 years the technology changes. So the technical specification has to be approved by everybody. Then the design starts. Design evaluation, the preliminary design review, critical design review, and the very CPs of iterations. Thereafter, you start manufacturing your LRUs, the line replacement units systems, and you will undergo at various levels of testing, system level testing, aircraft level testing. It is going on all parallel concurrent activities will go parallelly at the various centers within the campus and even the outside the campus. The day you are matured and you are finalizing the standard of preparation of the aircraft or helicopter, what the hardware is going to be installed, what the software is going to install, and what is the weight, what is the CG. You are finalizing the prototype of the aircraft or helicopter. It is very configuration of the configuration for the first flight. Once the configuration is finalized, once it is meeting all the requirements, the first prototype flight testing, the Semilac will give the clearance for the first prototype flight testing. Then flight testing will go on. During the flight testing, you are carrying out various flight test activities. You are acquiring the data, and finally you are analyzing the data, seeing that whether it's meeting the design requirement, performance validation, and once it is meeting and type approval, all the LRUs you are getting certification, and the user evaluation. In many of the concurrent projects, users also participate concurrently right from the day one onwards, so that they are also part of the development. And finally, when it is meeting all the requirements, the release to service document will be issued by Semilac, that is in the form of initial operation clearance, final operation clearance for series production, and based on the IOC and FOC, multiple numbers are manufactured and delivered to that Indian Air Force. And of course, the continued airworthiness assurance will start from there also till the retirement of the platform. Now, if you see any design criteria, the aircraft, helicopter, you have to design each and every system with the reliability of the system. Like I told you, Boeing 777s, 20 hours non-stop flying, after 4 to 5 hours gap immediately coming. So how much reliability has to be built in each and every system? And the damage tolerant fail safe. Nowadays we are using several composite structures. The composite structure is called damage tolerance. So little amount of fail has to be tolerant. That's for damage fail safe. High TBO life. Each and every aircraft, the day you build, it has to undergo a overall within a scheduled interval. That is called you have to design for high TBO life. Then any product is have a less vibration and less noise and crashworthy features. In the fighter aircraft, whenever you are in emergency, try to save the aircraft. If not possible, we can reject. You can leave the aircraft and come out and land safely. Whereas in the helicopter, no, that is not possible. You have to eject, no, it's very cumbersome. You have to eject the rotor, everything. That's not possible. So when you are doing a high level impact, the seat, that is the helicopter structure, and the seat will take care of your crash. The crash for the features built in. Good handling qualities is applicable for the fixed wing and rotor wing, and safe life component. You are familiar with fail safe and safe life. This is the design criteria for any product in the aviation. Now, airworthiness in the design. When you are launching any design, it's a passenger aircraft or a fighter aircraft or an helicopter, you have to estimate the load coming on each and every component accurately. Your estimation wrong, it will show in a different form of failure at a later stage. So the starting will be your estimation of the loads through using the wind tunnel and the other tools and softwares. That will be very, very accurate. And after this, you are ensuring airworthiness parameters during design itself. When you go to this one, you might have a familiar factor of safety. If 100 kilo coming on any component in the actual scenario, to design the design load of 1.5 factor of safety. Thereafter, the margin of safety. This margin of safety in any analysis, any data, should be always positive. What is margin of safety? The capability of the height structure, and what is the ratio between capability of the stress minus 1. Okay, it should be always positive. If we see any construction, it has got a casting, it has got a welding, it has got the joints and the composite structures. So in the design itself, you have to take care of that. If you are using that ultimate tensile strength, when you are considering ultimate tensile strength, whenever you are using a welding structure, you have to weld factor, casting factor, the joint factor, and the environmental degradation factor for the composites. Normally, you will say 1.2 for the environmental 20% reduction in strength when you are exposing the composite materials to that humidity. Like that, that's why you are using the factor of 1.2. Then the effect of temperature on the strength of materials. See, when the temperature is high, the strength is coming down. So the strength of the material at elevated temperature is low. So what temperature your structure is or your system is operating, that temperature, what is the strength, that you have to consider during the design. Selection of the aviation standard material is very, very important. Today, in India, in aviation, you cannot use any material as you like. There are aviation standard material available, you use only that. Same specification, commercial material also available. What is the difference between commercial material and aviation standard material? Aviation materials, your property variation is very, very narrow margin. So you are doing the analysis and the variation will be by considering 1.5 factors of to compare everything. Where we go to commercial material, the variation properties very, very wide. That is why we always go for a aviation standard materials designed for adequate fatigue life. When Air Force is asking for any fighter aircraft, they will say, I want so many hours, thousands of hours of fatigue life. So your design has to cater for carrying to meet that much fatigue life. In always the fighter aircraft, it has got a few thousands only because it do all kind of maneuvers, pulling 8G, 6G, it will undergo all kind of maneuvers. For that, you cannot design an aircraft for infinite life. If you design for infinite life, the weight will go on. So you cannot able to, the aircraft may not be agile and may not be able to do that all kind of envelope. So that's why design for a limited fatigue life, and the aircraft has to do like all kind of maneuvers. Whereas in the passenger aircraft, you'll take off with the passenger and the cargo, have a level flight at a optimized height, go and land, will not undergo any kind of maneuvers. Then finally, the design for manufacture and machine maintenance. Any design, end of the day, it should be manufacturable. And if your drawing goes to the shop floor for manufacturing, the manufacturer say, yes, without any hurdle, without any problem, I will be able to manufacture. That is for a good design. At the same time, you are manufacturing your assembly and you are releasing the aircraft to the user. Tomorrow it should be maintainable. Okay, you cannot say after each every flight I have to inspect everything. That is not a good design. Then design to operate under extreme environmental condition. I told the Indian map. It has got plus 55, minus 55, silent atmosphere. When you are operating, particularly if you are operating the Jamnagar, no, they are coastal area. And they leave the aircraft next day, the saline atmosphere over the surface. There is an instruction when Chetak helicopters are operating over that ship, and after each and every flight, they have to clean the main rotor surface with a clean distilled water like that. Because the saline atmosphere will stick to the surface, and lactose, if it continuously there, it will create corrosion on the surfaces. If corrosion is there, degradation of the properties. So that way, what you are designing, what your selection of the material, what the coating you are giving, what the painting you are giving, that you will be able to withstand the extreme environmental conditions. And of course, it is one of the requirements for today's scenario. It is a low operating and maintenance cost. So, right from the design tool, it has to meet all these requirements. If it is meeting all the requirements, the product what is coming out has got a good value in the market. If you see the aircraft system, any aircraft take varieties of systems: aerodynamics, structure, flight control, cockpit and control display system, lighting system, electrical system, avionics system, power plant, fuel system, hydraulic system, landing gear, brake management, environmental control system, life support, armament, escape system, brake parachute system. And all the aircraft is divided into individual systems. The individual system has to undergo a component level, subsystem level, system level qualification testing. When it is meeting all the requirements, they are all put together, then you are doing testing. That is the airworthiness requirement. You cannot, if it today LCAPC, it has got 365 systems installed on the aircraft. You cannot build a aircraft installing all the system, directly go for the first flight. No. Each and every system has to undergo individually the qualification testing. The day it's meeting the requirement, satisfactorily, the Semilac will give the approval. That is why you are maintaining the airworthiness and safety. How? So, I tell you a typical procedure being followed in the aeronautic houses for certification of a mechanical system. So, first of all, in that aircraft, there are some critical systems, there are non-critical systems. I cannot ask for a very stringent qualification testing for a non-critical systems. Similarly, I cannot say for a critical system, I cannot do a very less qualification testing. So that is very, very clear, important. In a system of a aircraft, the various systems, the structure, the classification of the items. It is critical or non-critical. It is applicable for a system, applicable for LRUs, applicable for components, and each and every component I'll come little later. And for classify the system, follow system safety assessment approach for classification of the item. What is the system safety assessment approach says? A critical item, failure of the item will affect the flight safety. Very simple. If in an aircraft or helicopter, when it's flying, any failure of the system will affect the flight safety. If the flight safety is not there, you know what will happen. That is a critical system. In a non-critical system, failure of that item will not affect the flight safety. Even the failure is tolerable, and with the failure also you can fly. During the next inspection, you can detect what is the failure, can't be replaced. This is what the system safety assessment approach being followed for classification of any item, whether critical or non-critical. The criticality of the item is decided by the designers who is designing the system, and the regulatory authorities, I mean the Semilac. They will decide which is critical, which is not critical. Critical system has to undergo what kind of qualification testing, non-critical item has to undergo what kind of qualification testing. It is a mutual understanding between the designers and the regulatory authorities. Now I'll say one example. This is Semilac left side, the certification agency, contractor. Is a contractor, is a DRDO or HAL or Bell or a private. Both of them, first they have to understand what is the requirement of the system. What the system for is a landing gear. Is a landing gear what is supposed to do? A flight control system, what is supposed to do? So once you understand the system requirement, you have to evolve the specification, the approval of the specification. Once the specification is approved by both the designer and the certification agency, there will not be any confrontation at the later stage. Okay. Once the specification is approved, after that the design starts, analysis of the design. That preliminary design review, critical design review, then parallelly they'll prepare the drawings, what material to be used, what is the process to be followed. All the things will be approved by Semilac, and finally they evolved the qualification test schedule. Okay, it is a concurrent approach between the designers and certification authority. They sit across the table, discuss across the table, come to an agreement. That's why in each and every stage, both are in the left side and right hand, a close interaction with both of them. And one day, what kind of testing it has to undergo, that is called qualification test schedule, both of them will sign. Okay. Thereafter, parallelly the manufacturing will take place. The DGA will come in the picture. He will see what is the prototype drawing or process approved by Semilac between the designers and Semilac, and the first sample, article produced by the manufacturer will be inspected by quality control, the DGA. I told involvement of DGA right from the beginning will increase reduce the non-conformance. Okay, that is why their involvement will be there. Then, once they clear, the sample will be tested at the approved test house. Any developer, whether HL or any private vendor, he may not have all the facilities under one roof for carrying out qualification testing. He can go outside wherever the facilities are available. Nowadays, many of the private labs, they have got NABL accredited laboratories. They have got their test facilities. The product can go there, get it tested, and they'll get a certificate. So that it is between the quality DGAQB, and based on the test, after carrying out all the tests, they'll prepare a qualification test report by the contractor. Again, it has to go to the DGAQA coordination. So that DGAQA will be there fully in the picture. He will ensure the sample is manufactured as per the drawing. He will ensure the product is tested as per the qualification test schedule. He will ensure the certificate, the test report prepared by the contractor is in line accordingly. He will coordinate, and the document is submitted to RCMA, the qualification test reports. RCMA will go through, the RCMA Semilac will go through the test reports. If it is meeting the requirement as per the test schedule, if it is a critical item, the provision clearance will be issued by RCMA and Semilac, and if it is a non-critical item, there's a local type certification committee exists in each and every design house. They'll give the clearance for bulk production, and thereafter type approved by Semilac. This is what it is being followed. It is a critical system or non-critical system, or any avionic system or electrical system. This is everywhere. The methodology procedure is same. Only the variable is the requirement in the qualification test schedule that will be depending upon the critical item. The number of testing may be less or more, that purely based on the critical item of the system, but the procedure is same. If we talk about, there are today, the modern systems are avionics, maximum avionics and software oriented. They are also safety critical, mission critical. If you see the LCA DFCC, the digital flight control system is a critical system. If you see the safety critical, any weapon delivery or any other system, it is a mission critical. If you see what is the procedure now, everywhere same. Specification, design reviews, finalization of drawings, bill of material, finalization of QTF, SOF, environmental screening, qualification testing, limited qualification testing, analysis of QTR, everything is same for a mission critical as well as safety critical. But the software certification has to be carried out much before the first flight testing, for the safety critical. Whereas for the mission critical, based on the functional testing, they will give the clearance. There, after completing that flight testing, you can do software certification also. That is very, very critical, because today in a AFCS flight control system, this is software driven. If at all any bug in the software, you know what are the implications. So the software also has to undergo a testing. and a separate volume is there for software certificate, then flight testing, again the clearance for service use, bulk production. Okay, here also same thing. This is the procedure being followed for avionics system of critical, say mission critical. This is the software certification process. Over in the software, the day feature, some of you are come across these kind of requirements. They will be familiar. These also various requirements for a software development, software certification, and documents. This also depends upon it's a safety critical at level A, level B, level C, level D. There's a international standard RTCA BO 178B standard talks about various levels of certification for software that is being followed by all the aeronautical institution in India. I told you all these different stages, right from the requirement comes from the services, then those things has been converted into specification. Based on the specification, you are estimating the load, you are doing the design, analysis and production, and doing the ground testing. From the ground testing, you are evaluating the flight deliverables, and you need to, when the day it is meeting the safety requirement, the Similac will give the first flight clearance for the flight testing, and thereafter flight testing will start. You are measuring the various load coming on the critical components and comparison with the design, whether what the measured loads, whether it is as per the design or not, and the comparison with the analysis, and finally the entire product. You are seeing the design validation and the documentation, and finally the operation clearance to the services issued by Similac. Now, what is the clearance talks about? You see, each and every system will be given a clearance separately. If a landing gear system, landing gear will itself will have its own independent clearance. So what Similac does, they will give the clearance to the part number, part name. And what is the clearance will talk about the details of the approved drawings with issue numbers. The drawing also they will approve. And once after getting the clearance, you cannot change the drawing on your own. Okay, the specification of the material, alternate material to be used. During the prototype, you may use one material. It will undergo all the qualification testing. You will meet the requirement. You will get the clearance from the certification authorities. During the bulk production, you go to market, the material may not be available. Okay, you cannot use the material as per your choice. In the drawing also talk about what is the material to be used, what is the alternate material to be used. If both are not available, you cannot use on your own. Okay. Thereafter, bulk production, that the DGA comes, you will say, show me the drawing, what material you are supposed to use, what material you used, please show me the records. You to interlink, you are used the correct material used. Like that. Then process. In what kind of heat treatment you have to use, coating, finishing to be followed during manufacturing of all the components. Acceptance criteria, permissible manufacturing tolerances. Okay. There is a saying there is no, in aviation there is no deviation, there is no. Okay. There are some tolerances. You have to meet the requirement within the tolerance. Okay. And life of the item components. It is applicable for the item, applicable for self, applicable for aircraft also. Then, see today, if you are giving a certificate today, and you are manufacturing 20 or 30, 20 helicopters, 20 aircraft per year, your requirement will be 200. It will spread over 10 years to 10 to 12 years. Okay, and it will, that the tools and have its own wear and tear. So the certification agencies will also say the batch testing, one in so many numbers, to test, to ascertain the consistency in the quality during production. Because you see that commercial aircraft now, they are manufacturing hundreds of aircrafts. So after each number, you are ensuring that consistency in the quality, that's why the batch testing concept comes. Inspection criteria during service, that is very important. And on the delivery, what kind of inspection he has to do, and limitations and conditions. This clearance we are giving to one organization, it is not transferable to any other organizations. And today, DRDO is developing one system and is getting the approval from Semilac. And DRDO is not a bulk production agency. He will give the technology to some other agents. So when you are giving the TOT, transfer of technology, okay, you'll go to some private or PSU. The first item manufactured by the TOT partner shall undergo a limited qualification testing to ascertain that the TOT partner absorbed the technology properly. Originally, the designers and manufacturers fully familiar with each and every intricacy of the system. The day you are transferring the technology to a third person, he may not fully familiar, sometimes he may forego something. Therefore, to see whether he has observed the technology correctly or not is the concept of repeat qualification testing, okay, to a certain extent. Of course, what is the level of qualification testing it has undergo? The designer, the certification authority, and the TOT partner will sit together and they will decide about what are the critical parameters. And during the bulk production, the manufacturing agency should not deviate the above without the prior concurrence from the regulatory authorities. I told you no, the drawing calls for one material, it is calls for alternate material, he goes to the market, both are not available, and if it's not available, it's heavy cost, he cannot use the material to his choice. No, he has to come back to that regulatory authorities and he say, these two materials are not available, can I use this? With their concurrence only, they have to use. If without their concurrence, if they use tomorrow, if it fails, no, you cannot ensure the safety and reliability in the product. That is why when Similac gives the clearance for any number, anybody know, the clearance will become null and void in the event of change of manufacturer, change of manufacturing place, change of drawing, change of material, change of process, etc., without the concurrence from the certification authorities. Why I am telling you no? See, today it is not, it is a general human nature. I'll buy the technology, I'll buy the transfer of technology, I pay after paying certain money and everything, I want to make quick money. So when you want the profit margin to increase, always will see your manufacturing cost will be less. In that bargain, you will compromise anything on the material and the manufacturing process. That is not possible in the aviation because safety is the paramount importance. That is why in aviation, the Similac will always give you a direct class, and tomorrow, if you happen to come to know if you are using alternative, all the clearance will be null and void, will be cancelled also. That way, this aspect is being maintained and the clearance is issued the part number and part number. You can say, if the LCR, the ALX has got thousands and thousands of drawings. Okay, how Similac can give a signature on each and every drawing? No. All the drawings, master print list will be taken. Okay, and that master list, they will seal it. The sealed list will be kept on one place. And if he suppose by chance if using some other drawing, no, he can always take it out and cross check with the master list. Oh, he is using the correct drawing or not. That is why correct drawing in the sense what is the issue number, release number, everything is put. It is in the aviation, no, this is the practice being followed and nobody will deviate, even though whoever has deviated, they are ended up in problem. This is the practice being followed right from the rivet up to the aircraft. Okay, that is why in order to ensure the safety, quality and reliability. See, you can see this is a rivet. See where the arrow is, the cursor is there, it's a rivet. Okay. It's a cable, the tire, the grease, the gearbox, the battery, the filters, the valves, the bolt, anything, everything. Very, very right. It is once a rivet. Okay. The rivet will be weighing about maximum that 3, 4, 5 grams like that. Even the rivet, you can say, is a rivet, a simple rivet. Even though it is a rivet, it has to undergo a qualification testing to the requirement as possible as per the standards, and a clearance will be issued to the rivet. Because the rivet, if you are using in a critical system, if it fails, the entire system will be in jeopardy. For jeopardy is safety and reliability. So what I want to say now, in aviation, each and every component is very, very important. If the rivet you are using in the critical system is becoming a critical, the same rivet you are using in a non-critical system is a non-critical. Usually it's a refinery. Our semi-lab scientists will go audit what is the process being followed for manufacturing of the fuel for aircraft, helicopter according to the certificate. So this is a brake parachute. You name anything, they're all certified by semi-lab. Similarly, I talk that aircraft, helicopters, upgradation, everything, it has to be certified. And during for a bought out aircraft, a license built aircraft like Jaguar, MiG-21, MiG-27, Su-30, and even a bought out aircraft like that is Mirage 2000, when you want to introduce a system that anybody, suppose spare may not be available from the original equipment manufactured in the foreign country. Just because if it is not available, you cannot keep the aircraft on ground. So you have to develop the spares and systems. Yes, you are allowed to develop with the use of a HAL or private organizations. The item which is developed has to be certified by similar for use by services. Okay, the procedure exists, and we have cleared so many systems, several systems for a bought out and licensed aircraft. For everything, similar case cleared, and so that to ensure that the aircraft, helicopter never be on AOG or want of spares system from abroad. If you see the Indian aviation, go to Indian aviation. Over 6 decades of experience in India, HAL, TRDO and CSIR are that organizations were involved in development of aviation products. If you see our olden days aircraft is made out of wood and cloth. Today, the aircrafts are manufactured out of composites, carbon composites. And then, see the cockpit. It is made out of dial gauges, and today the glass cockpit. The control system, the push-pull rod system, now with the fly-by-wire and in future fly-by-light and fly-by-sound. Okay, and we are manufacturing, we are seeing the license production, upgrades of aircraft, helicopters and engines. Let's see, 1958 Indian aviation started. In 1958, we are using the bought out aircraft Canberra, Hunter and Packet. And we have migrated to license production. License production in the sense, the foreign country will give the drawing, will give the material, give the manufacturing process, give everything, assembly process, procedure, everything. We have to build to print and then manufacture to the approved drawings. That is called license production, you give everything. And some of the key systems you will be supplying. So from there we are migrating, expanding. Today we are in a position to design our own aircraft, ANWC, Light Combat, AE, LCA, AVAX, ARC, ALH, LCH, LUH, all of the systems are aircraft, UAV, Rustam everywhere. Okay, that technology, Indian technology has advanced so much. We can develop, design and develop to the requirement, to our own services requirement. The prestigious light combat aircraft, designed developed by ADA in coordination in association with HAL and many and various organizations within India. It has been designed with the state-of-the-art technologies like zero-zero ejection seat, advanced avionics, glass cockpit, advanced materials, composite, general systems, coordinated digital flight control systems, and whatever technology available is a 4.5 plus generation fighter aircraft, whatever technology available today, everything has been developed and incorporated in the LCA. I told you the systems, all other systems you have seen earlier. These are the systems, different power plant, fuel system, hydraulic system, landing gear, brake management, life support, armament, escape system, brake parachute, all the systems has been tested individually in each and every rig, ground testing. Good. As a landing gear separately, Ironbird, lightning facility, each and every system has been tested individually. And end of the day, see, it is meeting the requirement as per the specification. Once it is meeting as per the specification, Semilac will give clearance for the individual system. Thereafter, all the systems have been integrated on this aircraft and the ground testing at the aircraft level. Here also, the entire airframe is undergoing the load test, the strength test inside the HL campus. Okay, so as I told you earlier, each and every system, right from the rivet up to the aircraft level, it has been tested so as to ensure that it is meeting the airworthiness requirement, it is meeting the design requirement, it is meeting the so as to ensure the safety of the aircraft. This is the Ironbird. All the systems, hardware, I told you, and software integrated on this rig, and complete evaluation will be carried out before clearing for the bus flight. It is a complete aircraft grounded to the ground. It has got all aircraft system except the shape. Shape only it is not there. Otherwise, it is a full aircraft. It has got everything. All the system integrated, and like a pilot sitting, he will operate all the systems and see it is meeting the requirement, meeting the safety requirements. So once it is meeting the safety requirement before the first flight, Semilac will give clearance for the first flight. The flight has taken place in the year 2001. Thereafter, the series of flight testing is going on. High altitude testing, air-to-air refueling, high altitude testing, air-to-air refueling, the bomb release. It is for the naval version. It has to land on the ship. Before that, it has to be proved on the takeoff and landing from the shore-based test facilities. It is one of the requirements. Any fighter aircraft, the endurance is limited because the fuel carrying capacity is limited. With that fuel, he has to land for refueling. So to increase the endurance, the mother aircraft in the air, while flying, it will fill the tanks. This is LCA is getting fuel from the mother aircraft IL-76 in the air. So I told you flight testing of the aircraft helicopters. I told you in the beginning, you decide about the standard of preparation of the aircraft, what is the hardware has to go inside, what is the software, what are the critical and non-critical systems, and weight. Okay. Now, when you are doing the flight testing, you have to do the flight testing different all of it, the minimum to the maximum all of it. And tomorrow, when you are getting the clearance from the Semilac also, that the clearance will go to the service also. You will say what is the permissible takeoff weight maximum and what is the permissible minimum landing weight. All those figures will be written in the flight manual. The flight manual will be approved by Similac and the pilots will follow only the flight manual only in the squadrons. Okay. When you are doing that, no, in the different all of weight of the aircraft has to meet all the user requirement. That's why the different all of weight, different CG conditions, forward, CG, mid CG, up CG, and different speeds, different attitude, and within the flight envelope to the aircraft design, the flight envelope, the VN diagram, the velocity versus load factor diagram, it has to touch the corner point of that flight envelope and carry out the testing within that envelope. Okay. Different altitude, sea level, altitude, sea level is a must to prove the descent capability, that is what the sea level performance, and beyond up to the maximum ceiling to which the platform, the aircraft, the helicopter is designed. Extreme environment condition. I told you the India map, hot weather trials at Jodhpur, cold weather trials at Leh, and in July, August, Leh, high altitude and hot weathers. All of you know the high altitude, the density of the air is less, and your power requirement of the engine also is. So you have to prove your performance at that particular critical requirement, high altitude, hot weather trials, particularly Leh, airsfield day, you have to take off and land with that environmental conditions, different crosswind conditions, landing conditions, wet runway. Yes, in the rainy season you have to come and land on a wet runway, slope landing and landing on a grass and concrete for the helicopters, and flight testing for the firing of missiles, rockets, any fighter aircraft. You'll have to have a clean aircraft, you'll have a missile, you'll have a rocket. Flight testing of the special equipment, flight testing demonstrate emergency procedure, and flight testing to train the pilots. After carrying out all, the light combat aircraft was given a final operation clearance and released service document for the Mark 1 on 21st December 2019 during the air show. Okay, this is a certificate issued by the HAL, ADA and Similac. Based on the certificate only, the user will operate the aircraft as per the guidelines stipulated in the released service document. Similarly, one of the successful product, ALH, I don't want to go through. There are also indigenous developed with state-of-the-art technologies. I involved in the project for about 23 years. And I told you no, the gearbox. To decide of the fatigue life of the gearbox, it has to undergo a fatigue testing, reaching the rotor loads and the control loads, all loads before it is to be inducted into service. This is that complete fuselage is under testing. Is the flight testing. High altitude cold weather trial. It is landing on the ship. And today the prestigious advanced light helicopter designed by HAL is in service with all the services doing extremely well. And these are all the products certified by Similac, light combat helicopter, light advanced light helicopter, light utility helicopter, ANWC, LCA, DRDO operating testbed. This is Astra missile firing from Su-30, the integration of BrahMos missile from Su-30 firing trial. This also Similac has contributed extensively in integration of the missile and firing from the Su-30 aircraft. Now, having told your excellent design, excellent manufacturing facility, excellent quality control, and finally, maintenance of the product is very, very important. Even an excellent design, better quality, and high reliable product, we cannot ensure safety if not maintained properly as per the maintenance schedule. Follow the maintenance requirements stipulated by design and regulatory authorities strictly. There are daily maintenance, weekly maintenance, monthly maintenance, yearly and hourly overall. Carry out major servicing of the overhauling of the system within the time schedule, replacement of the item overall, and use correct consumables. Adherence to the lifing document, replacement of the components items, proper documentation of the work carried out for proper traceability in the event of any accident or incident tomorrow. You should be in a position to trace back what you have done on the systems. Strictly follow the flight manual and emergency procedure. This is for the pilots. In a summary, safety is a critical parameter in the aviation with a zero tolerance. Safety requirements to be built in design stage itself. Safety aspects to be implemented in each and every stage, right from design, manufacturing, ground and flight testing. Safety norms to be followed by all concerned organizations, designer, manufacturer, maintenance personnel, and finally users and operator. Documentation, I told, very essential. Safety is everybody is concerned. Certification and quality control by external organization is essential to ensure the safety of the product. I mean the aircraft and helicopter. This is very, very important. Always a third party is coming and auditing your system. You will come to know a lot of non-conformance. That way, it is an aircraft, external agency certification is very much essential. By adhering to this, safety is ensured and result in every flight will be a successful flight. Thank you very much.
Thank you, sir. Thank you so much for giving the very good information related to airworthiness and certification. Dear participants, if you have any queries, you can ask. Sir, the few participants have some queries related to this particular session.
No problem, they can ask now also. Even as Dr. Tengli told, anytime they have got any clarification, they can contact me. I am ready for clearing anybody's doubt. Okay.
So few participants have asked the questions in chat box, sir. We request you to address.
Yes.
You read it.
Sir, what are all the materials for aviation, like this certification, what they have using? What is the difference between the commercial and aviation materials?
I told aviation, no. See, in aviation, you are using aluminum alloy, titanium alloy, steel, composite material, etc., etc.
Yes.
Same material available in the commercial, also commercial material. But you cannot use commercial material. Reason is the aviation, no.
Yeah.
The properties of the material, your ultimate tensile strength, yield strength, and your percentage of elongation is in the having a very, very close bandwidth. If you see, a steel is variety 30 grams of steel is being used extensively in any aircraft. That has got a ultimate tensile strength of 110 kg per mm square. The tolerance is plus minus 10 only. Whereas the same material, if you go to commercial, no, the tolerance may be 80 to 140, 120. You may be assuming its strength is 110. The material which is supplied is having a UTS of 60, only 50% of the strength. Tomorrow, during the operation, it may fail. That is why we always in the aviation, you have to use aviation standard material only. And the majority of the materials we are importing from abroad, and some of the steels also indigenously available within the country. Some of the organizations at Ambachari, aluminum alloys, they are developed within the country. It is available. Midani, okay, DMRL Hyderabad and Midani. There are steels, titanium available within the country for construction of the LCA, ALH, and other materials. So that is why we are using aviation standard material in aviation.
Okay, sir. Next question. So whether the abroad aircraft like Rafale, they need to undergo the mandatory checks in view of aviation safety or?
Now, what happened when any bought out aircraft comes to India?
Yes.
Services will operate based on their country of origin certificate.
Okay.
For example, MiG-29, your Mirage 2000 and Jaguar. And tomorrow, when you want to do a modification, when you want to upgrade the systems, it has to be with a concurrence, clearance from the certification agency, that is by similar. Okay? And when the aircraft is coming along with the aircraft, they'll give what is the schedule, what is the maintenance schedule, what is before flight, what is to be done, after flight, what is to be done, weekly maintenance, monthly maintenance, everything is written. The maintenance personnel, they will follow everything. In the event of they want to change any SOP to the aircraft, they want to do any modification, anything, no. That has to be analyzed or audited by a airworthiness authority. That is in India is SEMILAC. So with their clearance, the modification will be incorporated on those aircraft. For operating in the flyover series, we don't come in the picture. Okay, based on the country of origin certificate, based on the country of the origin certificate, they can operate.
Okay.
Okay.
So then why the UAV certifications are not taken by the Similac?
Weaponized.
Weaponized UAVs.
Now, AD is developing Rustam 2. Okay. It's an unmanned aircraft. It is a medium altitude, long endurance UAV. Like any other manned aircraft, Similac also involved during the design and development, and the first flight was taken place with the clearance from Similac 1D. Okay, it is for a military purpose, and we are also carrying out the concurrent certification along with the designers, and each and every flight what is happening at Chitradurga, it is with our concurrence, with our clearance, Similac clearance only. Okay. We are also certifying the UAVs for military applications. However, for civil, the DGCA is there. That now the DGCA has given the control to QCA, Quality Control of India. They do certification for all drones used for commercial purpose.
Sir, any permissions need to be taken to develop any spacecraft or aircraft?
Can you say again, please?
Sir, any permission is required to get from any authority to design and develop any aircraft or the spacecraft?
Okay, now, where is the requirement? For any development, you incur a huge money. Okay. So, whoever wants to invest money, you will see for a ROI, return on investment. Okay. Further, there is be a requirement. If the requirement is there, we can develop. Nobody is stopping you. Okay. And it has to undergo, say whatever we can develop. Finally, the requirement, you have to put somewhere on the aircraft. And the aircraft is required. You have to integrate the system of the aircraft. You have to do the play testing, everything, which involves a lot of manpower and money. Okay. That way, anybody can develop anything, provided the requirement is there. Okay, and this under Make in India, there are a lot of opportunities for in the Indian industries to be with the MOD for development of various systems.
Sir, you have elaborated very nicely about aviation safety. It was really a very good talk. And just I would like to know, since this safety has to be given utmost importance in aviation, so is there any health monitoring of the subsystems, whether anything has been developed to give the coverage for the entire aircraft, so that in case of any accident takes place or before accident itself, we can go for changing LRUs like that. And if any accident takes place, what is the root cause analysis of that particular LRU, that will help to analyze and then know which may be the root cause for the accident. So, is there anything developed, sir, in totality?
Yes, sir. I'll tell you. Each and every aircraft or helicopter is integrated with a flight data recorder. You can say a black box. In the paper, you can see black box. The flight data recorder, depending upon the capability, the moment you switch on the engine, it start recording various parameters. Okay, and after you land, it will have overlapping will be there total capacity, what is the endurance. After that, it automatically errors. So each and every critical parameters, the aircraft or helicopter, it will record. It is called the flight data recorder. Suppose there is an accident, immediately we go and recover the flight data recorder, and we decode what is the recorder says, everything, all the parameters. From the parameter, when the moment FDR is got after decoding, you will 100% sure you will identify the cause for the accident. When I was serving in RCM in Nasik as a scientist B, I participated in 7 quota of inquiries of MiG-21 aircraft. Okay, there is analog system, Sharpapa. Moment any accident is a fatal or non-fatal, you retrieve the flight data recorder, do the analysis, decode, and by studying those parameters, you will come to know is a pilot error or a system fault, everything. It is weakening. Only one of the case we could not able to locate the FDR, there only we have this one. So what you asked, the health monitoring system. Yes, the modern aircrafts are having inbuilt health monitoring system. Okay. I told you the fighter aircraft, it will undergo a series of maneuvers and critical maneuvers. There's a fatigue meter is there. It will record G. In a system, so the accidents of G so much number in the 100 flight hour, this much accidents like that, That the health monitoring system, inbuilt systems are there. It will show the health of the aircraft, okay, very clearly. And during the prototype testing, because you are carrying out the complete ground testing and meeting the requirement, clearing for the flight. After that, it has got lot of instrumentation on the first prototype. And when he is flying, you can sit in the ground flight test center, and each and every system, it's a hydraulic system or fuel system, each designer will have a big monitor in front of him. What is happening in the system, the aircraft while flying, everything will be displayed on the ground. Okay, each and every designer, they are monitoring the satisfactory operation of the systems while flying on the prototype aircraft. Okay, if at all any system, it is going to immediately with the instruction, if the system is not working satisfactorily, please land. That is for the initial prototype. After carrying out series of flight testing, when the day maturity is happening, the ground telemetry is removed and it is cleared for playing with only the flight data recorder. Now, LC also has got an inbuilt health monitoring system. The moment you land, go and offload, you'll talk about each and every health of each and every system, so that based on this, what is the precautionary measure that to replay the system or not, take it out. The same thing is being followed for a commercial aircraft. Okay, the moment it landed, they take out their data and send it to some of the organizations. They will do the analysis, immediately say everything normal, you can go ahead for the next flight like that. So that is the system is available within the country. They developed with the RIS developed and available for almost all the commercial aircraft, and in LC also it is there. Is it answering your query, Dr. Tangli?
Yeah, it is fine.
Yes.
Okay.
Hello, sir. I'm Akhil. I have a question, sir.
Yes.
Sir, this Pratt & Whitney PW1100 engine inducted in Indian commercial airliners, it has a problem with the low pressure turbine blades. During the third stage, in the third stage, due to some problem in the turbine blades, it reduces the thrust value. So my question is, why did after all this sophisticated testing, how did we not find this problem before inducting this? Yes.
Yes, it's a very good question because that commercial, what is that? Civil aviation.
Yes, sir.
FAA. They are supposed to capture each and every aspect during the testing. Okay. And how it is the overlooked now? Probably they only will be able to give the reply. Okay.
Okay.
You got the point. It's basically civil, and finally it's being cleared by FAA. Okay.
Not safe.
And that's why I told during as an engine it has to undergo in the standalone configuration each and every test up and establish all the satisfactory parameters. The day it is meeting the requirements, it is supposed to be released. And after that also during flight testing, they have to monitor each and every parameter during prototype flight testing. And how it is the overlooked, perhaps no, they'll be able to say. Okay?
Okay.
Sir, is there any difference in airworthiness standards for different classes and types of aircraft?
Sorry?
Sir, is there any difference in airworthiness standards for different classes of aircrafts?
For military aircraft,
yes, sir.
mission critical is very, very important. For a commercial aircraft, safety is very, very important. In a way, I'm telling you now, mission critical means in a war scenario, he has to take off, he has to go to the enemy territory, identify the target, deliver the weapons, and come and land. That is the mission he is supposed to do in the war scenario. There, he cannot say this mission is sometimes no, this mission is flickering and everything, this no. Okay, their mission is very, very critical. So, certain amount of the the safety and the airworthiness can be compromised there. Whereas in a commercial aircraft, the safety is very, very important, paramount. That's why the reliability figure is 0.999999. I told you, take off from Bombay or Delhi up to New York, flying over the sea. What the safety has been ensured, for the reliability has been ensured this way. So, the civil means very, very stringent. As military, the mission critical. That's why the airworthiness is, I told you with the acceptable level of safety and reliability is mutually agreed between the designers, operators, and the certification agencies. But the airworthiness requirements are same for every airworthy product. Is the same. Okay.
Okay, sir. Okay. Thank you, sir. Thank you so much for focusing on the topics like airworthiness and certification, which was very informative session for the participants. On behalf of Department of Aeronautical Engineering, so I would like to extend a big thanks to Dr. Jaipal P, former Chief Executive, Semilac, Bangalore. Thank you, sir. Thank you so much.
Thank you very much. And any student or any clarification, they can contact me. No problem. My number is there with them, and through you also. Dr. Tengli is there also.
Yes,
okay.
Yes.
Okay. So once upon a time, I was also like sitting in the students' gallery. Yes. Perhaps having so many doubts. Yes. Some students may feel shy whether to ask these questions or not.
Yes.
Okay. Yes. This is a part of the game.
Yes, sir.
After that, from the students, I went to that official that working this one. Now, what I felt that I should have asked that doubt that time like that. So, I am telling many of you will have some kind of shy in whether to ask this question or not. I think don't feel shy in the aviation. Always, whenever you have got any doubt, get it clarified from anybody, nothing wrong in this history. That is advice to all the students. Okay. Number two, as various students are listening to the presentation, always your foundation should be very, very strong. Sound foundation in the sense basic knowledge on the aeronautical engineering. Even 100 years back also, lift is equal to half rho v square SCL only. Now also half rho v square SCL only. Even after 1000 years also, the same only. So your foundation is strong. There, above the foundation, you can construct a new amount of building. So I advise you, all of you, all the my aeronautical engineers, students, please be thorough on your foundation. Thank you very much for your patient listening. Thank you very much.
Thank you, sir. Thank you for spending the valuable time with us and sharing your knowledge. Thank you, sir. And I would like to thank our participants for attending the first session of National Level Webinar Series Aerovision 2020. So thank you so much. So hope we are going to send you the link for tomorrow's session. So that will be from 12 to 1. Thank you, Vinod. And the session will be addressed by Dr. Prahlada Ramrao, Distinguished Scientist, DRDO, former Director, DRDL, Hyderabad. Thank you so much.
Indeed.